the last thing we're going to look at is calculating changes in energy. Now, we already did this when we defined the joule, but we're going to look at it a little more in depth now and look at different materials that would go through temperature changes. So we're going to be using an equation to calculate the energy and temperature that are needed to change each other. So the reason we look at equations like this in science classes is that we want to be able to quantify these physical phenomenon so that we can make predictions about them and that we can actually use them. So in a situation like an electrical plant, they would need to calculate how much fuel they would need to use to create a certain amount of electricity and then how much they should charge for that electricity. So they need to be able to do these kind of calculations. We're going to do a very simplified version of that. So the equation we're looking at, each of these variables represents a specific concept. So the E is energy, the M is mass, the C is the specific heat, and the T is the change in temperature. So let's look at what it looks like to use this equation. The worksheet that we're going to be working on gives you a table of the different values for specific heats for different substances. Now, what is specific heat? What does that mean? Well, if you think back to when we defined the joule, the specific heat was how much energy it takes to change the temperature of 1 gram of a substance 1 degree Celsius. So it's really how much energy is it going to take this substance to heat up? And all these different substances have different amounts of energy that they would need. So water, classically, where is it? Water takes a lot of energy for each gram. This is why our body temperature actually is very easy to regulate. It's hard for us to get too cold or too hot, which helps us survive. Now, something like air takes 1/4 the energy. See that? It's 1 joule per gram per degree. Water is going to be 4.18 joules per gram per degree. That's what this equation really means. It's if we want to calculate how much energy this substance needs to go up a certain amount of temperature, well, that's going to depend on its specific heat. So what kind of material are we working with, and how much of that material we have. So when you see the questions on this, how much energy would it take to heat up 1 gram of aluminum by 10 degrees? Each of the words in that question really correlates to one of these variables. Let's look at an example. How much energy would it take to heat up 10 grams of water by 10 degrees Celsius? Well, we're going to take that equation, this one right here, and we're going to plug these variables in. So first we need to look at our table and say, okay, the specific heat of water on this table, water is 4.18. 4.18 and then 13. Okay, so let's label which variables each of these things are. So my temperature change, that's going to be this guy right here. My specific heat, it's going to be this one right here. And my mass, it's going to be this one right here. So now that we know which variables are which, we just plug them into this equation. So all we would do is say, okay, we've got 10 grams, so that's going to be 10 grams times, let's use black for our math, so times, and that specific heat, that 4.1813, 4.1813, and then my temperature. So in all of these problems, all we're doing is looking at what's written here It's asking us how much energy would it take to heat up 1 gram of something. So we're going to figure out what's our mass. Well, that's going to be whatever is in grams, because grams is how we measure mass. What's our temperature? Well, that's going to be whatever has the degree symbol on it, because that's how we measure temperature. And then what's our specific heat? Well, we're just going to look at this table. We're just going to find it in here, and we just plug those numbers into this equation, and then punch it into our calculators. So if we do that, I've got this nice scientific calculator. You can barely see the screen because I don't have the lights on because they make a glare. Then I'm going to take 4.1813 times 10 times 10. And I'm going to get 418. So that means I need 418 joules of energy. There we go. So that's how we do these problems. So for this first page, all you're doing for numbers 2 through 6, so these 5 questions, all you're doing is plugging these numbers into this equation and calculating the result. Okay? Tomorrow we'll look more at what specific heat is, and then we'll look at the other questions that ask you to rearrange the equation. Okay? Good.